So this is a Exam 2 review video for spring 2025. So on this video, we're just going to work out the problems from Exam 2 fall 2024. The rest of the exam review you can find on other videos from past semesters' exam videos. So we're just going to do the most recent material for this video. Okay, so it says answer the following multiple choice questions. Okay, so assume the following information about the function f. We know f of 6 is 11, so I'm just going to go ahead and try to draw this out. We know that the derivative at 6, or f prime of 6, is 1/4, so some kind of a derivative. We know that the second derivative is positive, so that means the function is concave up. So it should be some sort of concave up function. And then the question, so this is my f of x, and this is my L of x, my linearization. Based on this information, which of the following statements is true about the linearization? So all of these are about 6.5. So I can go here and see the linearization should be less than, should be an underestimate. So L of x, L of 6.5 should be less than f of 6.5. Okay. But can I find the exact value of L of 6.5? So L of 6.5 should equal, 11. Oh, sorry, let me write it out this way. Should equal f of 6 plus f prime of 6 times 6.5 minus 6. So f of 6 is 11 plus the rate of change is 1/4, and then times 1/2. So that is 11.125. So L of 6.5 is 11.125, and that is an underestimate. So the correct answer is E. Okay, so for the next one, I'm given a graph of the derivative, and then it asks which is true about f prime of 2 and f double prime of 2. So f prime of 2, so this is the derivative. So I can see that f prime of 2 is 5, which is greater than 0. So f prime of 2 is greater than 0, so that's correct. And then I want to know about f double prime of 2. So f double prime of 2 will be the rate of change of f prime. So I can see that that's a positive slope. So f double prime of 2 is greater than 0. Because I'm given the graph of the derivative. So f double prime is the derivative of the derivative, so the rate of change of the derivative, which is a positive rate of change. So the correct answer is 1 and 3 only. Okay, for this one it says, for which of the functions would it be appropriate to apply L'Hopital's rule? Okay, so I can see that the limit as x goes to 1 of the square root of natural log of x. Okay, so as x goes to 1, the natural log of 1 is 0. So as x goes to 1, we're getting 0 on the bottom. So I need a function such that when x goes to 1, I get 0 on the top. Because to apply L'Hopital's rule, I either need a 0 over 0 or infinity over infinity. So what I want the limit as x goes to 1 of f of x to also equal 0, so that I have 0 over 0. So let's pick a function that works for. So as x goes to 1, sine of x does not go to 0. As x goes to 1, e to the x does not go to 0. As x goes to 1, this one goes to 0, so that's a possibility. as x goes to 1, secant goes to 1. As x goes to 1, sine inverse goes to, I don't know, something weird. Okay, the correct answer then is C, because as x goes to 1, x squared minus 1 goes to 0. So I'll get 0 over 0. Okay, for the next one, I'm given a graph and it asks for what values a and b does that equation have 2 solutions for some c in the interval ab. Okay, so let's just check each interval. So from -6 to -2, -6 to -2, when x is -6, we're like here to -2, it's here. So that only has 1 value, so it's not A. Okay, let's look at the next one. From -2 to 2. So at -2, we're here. So if I drew my secant line, there's only one point that has a tangent line in there. So it's not that one. Okay, how about -2 to 8? If I drew that line in, I actually do have 2 places, here and here. So I have 2 values of c there. So the correct answer is -2 to 8. So what we're looking for is that the tangent line is parallel to those secant lines. Okay, that's for the mean value theorem. On number 6, it says, given that f prime of -4 is 0 and f double prime of x is that, what statement below is true? Okay, so if I know that f prime of -4 equals 0, that means x equal -4 is a critical point. So that's a possible max or a min. Well, I can use the second derivative test to plug in -4 and see what that gives me. So that gives me 2 times -4 times cosine of pi times -4. So cosine of pi times -4, that's equal to 1, so I get -8 there. So what that means is that f is concave down, which means I have a maximum at x equal -4. So f has a local maximum at x equal -4. That one's true. Yeah, so that's from the second derivative test. So the second derivative tells us about concavity, and if we know that the function is concave up or down, we can tell if it's a max or a min. Okay, for this one, I'm given a derivative graph, and I'm asked, based on this graph, for what values does f of x have a local minimum? So I'm just going to draw out what's happening for this graph. So the zeros of my derivative are these values. So -8, -4, 1, and 4. And then I want to say, is my derivative positive or negative in between those values? So for x less than -8, my derivative is negative. For between -8 and -4, derivative is negative. From -4 to 1, the derivative is positive, it's above the axis. From 1 to 4, the derivative is negative. And from 4 to infinity, the derivative is positive. So if the derivative is negative, that means f is decreasing on these negative bits. F is increasing when f prime is positive. F is decreasing when f prime is negative. And f is increasing when f prime is positive. So if I'm looking for minimum values, I want to see when it goes from decreasing to increasing. So that happens here and here. So at -4 and 4. So the correct answer is B. Given that f prime of -4 is 0, and f double prime of x is equal to, oh, didn't I just do this one? Oh, okay. So if f prime of 4 is negative 4 is 0, that means f has a critical point at x equal negative 4, and f double prime of negative 4 should be 2 times negative 4 cosine of pi times negative 4. So this is going to give us negative 8, which means the function is concave down. F is concave down, so we have a local max. Okay, so the next one says, use calculus to determine the following. Find the critical points of f. State your answers in exact values. Okay, so what I need to do first is find the derivative, f prime of x. So that 1/4 is just going to stay put there. Then I'll have 3x squared minus 27. And so I can set that equal to 0. And so I can factor out a 3. So I get x is equal to plus or minus 3 when I take the square root. So those are my critical values. And then it says determine the absolute max and minimum. So what I need to do is plug in my endpoints and my critical points. Now, one thing you might notice here is that the critical point negative 3 is outside of that interval. So I'm going to throw that one out, actually. So I'll look at f of negative 2, f of 3, and f of 7. And so all I need to do is find the y values from my original function that go with those values. So for me, the easiest thing to do is to just plug that into my graphing calculator, into the graph, and then I can hit the trace button and type in those values. So if I trace at negative 2, I get that the answer is 8.5. If I trace at the value 3, I get negative 16.5. And 7, I have 35.5. So the biggest of these is the global maximum, and the smallest is the global min. So let's just write a sentence about this. So I can say f has a global maximum value of 35.5 when x equals 7. And I can say f has a global or absolute minimum value of negative 16.5 when x equal 3. Okay. And then the rest of these are from past exams that are posted already on the MLSC's website, so I'm not going to re-record solutions to those. You can just look at the past exam review videos. Thanks.